Yes, grade 7 girls, let us begin the new lesson, lesson 7.7, simulate compound events. It's like bring it to approximate. Example, the first one, what is that? Jillian lands the bean bag in the hole in about half of her attempts in a bean bag toss game. How can she predict the number of times she will get bean bag in the hole in her next 5 attempts? Okay, girls. She's like example, somebody gives you this bean bag and they ask you to put it in the hole. And how can she predict that the bean bag will go in the hole in the next 5 attempts? Makes sense. You can do any of the way. Okay. They said if the coin lands up tail, the bean bag will land on the board. That's half of the probability, 50%. If the coin lands head, the bean bag will not land the board. Again, half. So I can flip the coin 5 times to represent Jillian's next 5 attempts. So to check for five attempts, I will flip my coin 5 times. Nikki is planning a hike for the end of the week. I'm sure the example will be here. Let us try from here. It's the same example with the same number. It's visual learning.
To determine the probability of events. Think about this question during the lesson. Hike for the end of the week. She really does not want to hike if it is raining.
Can you hear this or no, girls? I don't think so. 1 minute. Let me play it again.
How can you use simulations to determine the probability of events? Think about this question during the lesson. Nikki is planning a hike for the end of the week. She really does not want to hike if it is raining the whole time, but is okay if it is cloudy.
Okay. She's planning for a hike, but what is the condition? She said if the whole week is not rainy, if it's cloudy, she will plan for the hike in the weekends. So based on the weather forecast, should she postpone the hike or no?
Based on the weather forecast, should she postpone the hike?
What do you think, girls? Thursday it's 40%, Friday chances are again 40%, and Saturday 40%. What do you think, according to you, leave about the question, what do you think? Should she postpone the hike or she should continue with it? Anyone can answer this, please participate.
Postpone.
Okay, postpone because it is 40%. Anyone else? Nikki must continue the hike or must plan for the hike or postpone it. The chances of raining is 40%. Anyways.
To begin, let's develop a probability model for rain on a given day. List the 2 possible events and their probabilities. The sample space, S, is rain and no rain. The probability of rain is 40%, or 4/10. What is the probability of no rain?
Okay. Now listen to this very carefully. This is a new lesson. Probability of rain is given to you as 40%, okay? 40% it is given to you. That means 4/10. When you do 40%, what is 40%, girls? 40% means 40 over, what is exactly 40 over? 40 over 100.
100.
Because this is percentage, you have to say that everything with 100. And you know that the 0 This 0, 40 over 100, the 0 and the 0 can be cancelled and we are left with 4 over 10, or divide by 10 to both the numbers and you get 4 over 10. So you have 4 over 10 here. I told you how it, so this is possibility of rain. So probability of rain. Probability of no rain, look at it. It will be 1 minus. It's a formula that you will always subtract with the whole number 1. But see how they do it.
Select your answer.
Okay. I always told you whenever it is no rain, like see, probability of getting this is 4 by 10. So probability of no rain will be 1 minus. This is what, like, you know, my teacher taught you. I don't know what procedure they are doing. Simple. 1 minus 1, 4 over 10. Just minus 1. Just minus the one whole number. Okay, here and here. I write 4 over 10. Now, when I do 1 minus 4 over 10, you know that this is nothing but 1 by 1. And you need to multiply the numerator and denominator with 1, with the 10. So you got 10 minus 4 over 10. 10 minus 4 over 10. So your answer is 6 by 10. This is according 6 over 10. And even one more thing you can do, girls. When 40%, so how much is left? How much is left, girls? If 40% is rain, so no rain is 60%. Do you agree to this? If rain is 40%, so how much is no rain? Percentage of no rain? 60%. That is nothing but 6 over 60 over 100. 60 over 100. That is equal to 6 over 10. Anything you can follow, either by dividing minus with one whole number or the rest of the percentage. Even this is easy, guys. When 40% is rain, 60% is no rain. So 60 over 100 is nothing but 6 over 10. Even here, 10 minus 4 here, 6 over 10. Now you will say, teacher, how do I get the 6 over 10? This multiply with 10 to make the denominator same. So same thing, you will multiply with the numerator to make the denominator same. And you get 10 minus 4 equal 6 over 10. That is the answer, 6 over 10. Now, Zishan, Dana, Majduleen, did you get this or no? You want me to explain again?
Yes.
Did you get it? Majduleen, did you understand?
Yeah.
All right. Let us see, 6 over 10.
In every probability model,
That's
the
the correct
sum of the
answer.
probabilities of the outcomes is equal to 1. The probability of no rain is equal to 1 minus the probability of rain, or 1 minus 4/10, which is equal to 6/10. How can you use a model to represent the situation?
So this is how I explained you. I said total probability of anything, that is rain plus no rain, is 1. That's why you subtract with 1. 1 minus no rain will give you rain. Every time this 1 is important, that you need to minus it with one whole number and then you will get the other number.
Next, we can model the situation by designing a simulation using a spinner. A simulation is a model of a real-world situation that you can use to find probabilities. This spinner has 5 sections of equal size. 2 of the 5 sections are labeled R for rain. The probability of R is 2/5, the same as the probability of rain. The other 3 sections are labeled N for no rain. The probability of N is 3/5, the same as the probability of no rain. Now it's time to run the simulation. Spin the spinner 3 times, once for each day, and record the results. Conduct additional trials.
So we said that with R,
Based on this simulation, Nikki should
with R and N, with yani rain, and there are 3 trials. If there are 3 trials, I mean there are 3 spinners. If there are 3 spinners, so first time R and N, and then NRN. These are the possibilities that you get on 5 trials.
should expect rain on one day of the 3 days. She should not postpone her hike.
So it's like there may be one more probability model that represents the situation. Drag the tiles to show whether the each spanner is correct in the model or not. Anyways, leave it. Try it. You have a question, try it. See in your book. You have a question, try it over here. That there is 50% chance that a volleyball team will win any of the 4 remaining games this year. A spinner with 2 equal sections numbered 1 win and 2 loss. The 1 is the win and the 2 is the loss. Is used to simulate. And they are doing how many trials? Maybe they are doing the last 4 games. The results of simulation are shown below. The results are given to you 1, 2, 2, 1, 1, 1, 2, 2, 1. These are the results. They're shown below. So out of 10 trials, how many favorable outcomes are there? What did they ask in the question? They asked for 50% chance that a volleyball team will win any one of its 4 remaining games. So means winning is, they said winning is 1. So 1 of its 4 games. So how many times do you see 1 only 1 time? 1 only 1 time. Let me check. This is 2 times. I get 3 times. No. Here I got 1 is 1 time. Because they said team will win any one of its 4. There are 4 there are 4 games this year. Any one. Okay, here they won 1 time. Here they won 1 time. And here they won 1 time. One more place maybe. And of course, once again, out of 10 trials, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4 favorable outcomes. The team will exactly win 2 of its 4 games is 4 over 10. 2 of its game. That means 1 has to be 2 times here, and here, and here, and here goes. Guys, give me a moment. I'm just back. So here, out of 10 trials, there are 4 favorable outcomes. What outcomes? The number 1 is the winning one. Here it is given that it will win any one of its 4 remaining games. A spinner with 2 equal sections, 1 is the winning and 2 is the loss, is used to simulate that the team will win exactly 2 of its last 4 games. How much they are asking you? They are asking to simulate the probability that the team will win exactly 2 out of 2 games. So means the winning is number 1. So 2 of its last 4 games means you have to see 1 must repeat 2 times. So in this one, here it is 3 times. I cannot take it. So here it is 2 times. The number 1. That means it's 2 winning. Here it's 2 winning. Here it's 2 winning. And here it is. So there are 4 possibilities out of 10. That's why we write 4 out of 10. I hope you got it. That's why coming here, I'll again show you here. One second. One minute, girls. Your book here. Zishan, please, can you read this out?
The Hornets and the Tigers will play a 5-game series with the winner of 3 games, named the state volleyball champion. The 2 teams are eventually matched. Use a simulation
To find the probability that the Hornets will win the 5 game. Okay. First thing, how many games are there? How many series? It's a 5-game series. Okay, like example, I will say that there are 5 series. If I win the 3 series, that means I'm the winner, of course. And with the winner of 3 games named the state volleyball champion, the 2 teams are evenly matched. Use a simulation, the probability that Hornets will win the 5-game series. Okay. So let us develop a probability model. Hornets win and Tigers win. List the event of probabilities. 50-50%. Okay, because there are only 2 teams here. They are Hornets and they're called as Tigers. And both of them winning chances 50-50%. Next step, we will design a simulation using a coin, and then we'll do with the, what you call as spinner. Okay, let us do with the coin because it is 50-50%. Let us say head and tail. So how many trials are there, Gus? How many series are there? There are 5 series. They said there are 5 series. So they run the simulation. For each trial, flip the coin 5 times to represent 5 games. Again, for one trial, I will flip the coin 5 times. So when I flip the first time, I have this one. Like that, I don't know why I did the 7 times. Okay, it can be less also, girls. There is not important that it has to be so many times. But they did this because we have all 7 options. Here the Hornets win because see, there are 3 times they win the game. So the Hornets win. Here the Tigers are winning. Now the question is, find the probability the Hornets win the game. Now tell me how many times the Hornets are winning. In how many trials the Hornets are winning. Please look at these trials carefully and tell me how many times Hornets win. How many times the Hornets win in these trials? 1, 2, 3, and 4. Hornets are winning 4 times again. 1, 2, 3, and 4. 4 times. 4 times the Hornets are winning. Now find the probability. Based on how many trials? 7 trials. We have to write based on 7 trials of the simulation. The probability that the Hornet will win is 4 out of 7. Hornets again, 1, 2, 3, 4. 4 out of 7. Okay. So this is the example given to you. Now next, I think we have a trial, or we have a try. After example 3, we have try it. Let me go to example 3. See guys, this is exactly as of your textbook. The one I'm doing there, the trials and the examples, exactly as of your textbook.